So Roman numeral 2, we are solving this function using first principle. So what are we going to do to solve this question using first principle? So everything is just okay. What we'll do is we'll say f prime of x equals the limit when h is approaching 0. Then we'll say f of x plus h and minus f of x over h. So we know the expansion of this. So what we'll do is f prime of x equals limit when h is approaching 0. This 3 will be written first. To say 3, then since x is squared, so we'll say x squared, and then we'll say plus, we'll say x plus h, and then we'll square this everything. Then we'll say plus, then we'll say x. So just say this thing, we'll just write it the way it is like this. So just say plus x plus h minus f of x is this function multiplied by negative, so that we have 3x squared minus x, everything over h. When you reach at this point, f prime of x limit when h is approaching 0, like this. The expansion here, we know to say that it is x squared plus 2xh plus h squared from the previous video. So what we'll do is we'll just multiply 3 to this, so that we have 3x squared, and then I'll say plus 6xh, then plus 3h squared minus 3x squared minus x, then everything h like this. So when we reach at this point, we are doing well in this question. So I'll rub the top part and then we'll continue. So there we'll say the f of x prime, meaning we are differentiating, we are using first principle now. We'll say this here, this one and this one, the 3x squared and the negative 3x squared, they can cancel like that. Yes, so these they can cancel, and I have this x, there is xh, so I've made a simple mistake. So it should be, everything is just okay for this expansion, but only that I need to write this part. I've forgotten this part, so I'll say x plus h like that. That's when I'll introduce the 3x squared minus x. So here, this x positive, negative x, and the positive x, they will come out. Again, the negative 3x squared and the positive 3x squared. So that in the function, I will remain with what? The 6x h, then I'll say plus 3h squared, and then plus 1h plus h, everything over. So don't forget about the limit. I'll say f prime of x, and I'll say limit when h is approaching 0, then the h will stand like that. Then from there, I'll continue the mathematics. I'll say now that it is like that, I'll factorize 1h. So I'll say f prime of x equals limit when h is approaching 0, then the 6, the h first out, so that I remain with 6x, then plus 3h, then plus 1 over h. this h and this h can come out. This implies that when we say it is approaching 0, now that's when you are saying f prime of x, will say limit when h is approaching 0, like that, at 6x plus 3h plus 1, like that. Since h and h has cancelled, when it is approaching 0, I'll say this implies that the 6x, then I'll say plus 3 by h, I'll put 0 plus, I'll say plus 1, like that. Meaning f prime of x equals what? Equals 6x then plus 1. So this is our solution. Remember, we had a question which was saying f of x equals 3x squared plus x. When you are differentiating a normal differentiation of using power, you say f prime of x equals these two multiply to 3 to get 6x. We are reducing this power by 1, so we say minus 1 here. Then you say plus. When you say 1 multiply by x, you get x. 1 minus 1 on top. Any number to the power 0, it's 1. So this expression you have f of x equals 6x then plus x to the power 0 here, which is just 1. So this is equals to this. So by power rule, you can prove the first principle that we've solved. Thank you so much for watching.